how to calculate limits of a function and to see two perspectives. One, how to use table of values method to find limits, and the other one will be algebraically. So talking about limits in simple terms is basically the y value that we get after evaluating. So we would want to see what is the corresponding y value when we substitute a x value. So let's see with some examples. So consider the function f of x is equal to x squared minus 4. Let us see what is the limit as x approaches 3 of f of x. So when we say x approaches 3 of f of x, that means we want to know what is the value of y when x is equal to 3. So basically we are substituting this 3 in place of x. So if I do that, now 3 comes here. So f of x means f of 3, which means 3 squared because x squared. So 3 is in place of x now, so we'll have 3 squared minus 4, and 3 squared is 9, and this minus 4 comes here. So 9 minus 4 we get 5. So in general we can say that the limit for this function is equal to 5. So let us use some other perspectives such as table of values of method, and let's see the behavior of this function closer to 5, closer to x equals to 3. So we are going to use table of values method. So before that we are going to denote with a number line. We'll put a number line first. In the middle we'll put 3 because we are approaching 3. So x approaches 3 from left. So this is how we denote x approaches 3 from the left. From the left we put a negative sign here. So x approaches 3 power minus here. So this minus indicates it's approaching from the left hand side. And similarly x approaches 3 from right. So from this side x approaches 3 from positive side. So we're talking about this arrow here. X approaches 3 from positive side. So this is the positive side, this is the negative side, or we say from the left and from the right. So let's see the behavior of y when x is approached from both sides. Now in order to approach 3 from both sides, we need some values closer to 3. So we need some x values from the left hand side that are closer to 3, and we also need some x values closer to 3 from the right hand side. So from the left hand side these are some values: 2.9, 2.99, 2.999 and 2.9999. So these are some values that is closer to 3 from the left hand side. And if we want to approach 3 from right hand side, we have to write down some values that are closer to 3. So some values closer to 3 from the right hand side are 3.1, next we have 3.01, next we have 3.001 and 3.0001. So as you can see, we are getting very closer to 3 from the right hand side. From this side we are getting very closer to 3, and from the left hand side we are getting closer to 3. So 3 is somewhere in the middle here. Now we want to see what is the y value, which is f of x. We would like to see what is the y value when these are the x values. 2.9, what is the y value? 2.99, what is the y value? 2.999, what is the y value? and so forth. Likewise from this side, 3.1, what is the y value? 3.01, what is the y value? 3.001, what is the y value? So this y value will also come towards a common y value, and this side y value will also come towards a common y value. So let's see from the left hand side. So for this one you get 4.41, for 2.99 you get 4.940, then 2.999 you get 4.994, and for 4.9 you get 4.999. So you can see these values are going towards a common value in the middle here. Similarly, we are going to see this side. So 3.1 is 5.61, 3.01 is 5.06, and 3.001 you have 5.01. Next we have 5.001. So these values are getting close to some common values, and that common value is basically 5. So we can confirm that the value that is in the middle here is actually 5. So that is why we say from the table it can be seen that x approaches 3 and f of x approaches 5. So when x approaches 3, we say y approaches 5. That is the meaning of limits. So limit is basically finding the y value when x approaches some value. That is what we said in the beginning of the slide. So let's move on. Let's talk about left-sided limit. So when we say we approach a number, or x approaches a number from left hand side, we denote as left-sided limit, right? So left-sided limit, this is how we do it. X approaches 3 from negative side, that is from the left hand side of the function f of x, we got 5. So we have seen that when we approach 3 from left hand side, we got 5. And from right hand side, we denote as positive. So as x approaches 3 from positive side of f of x, we also got 5. That was visible from the table of values method. So when these two limits are same, we get a two-sided limit. First one was left-sided, the other one was right-sided. So when both of them are same, we get a two-sided limit. And in two-sided limit, this is what happens. X approaches 3. Now we are not putting a plus sign here or a minus sign. We are removing the signs now. So when you don't see a sign here, you assume it's a two-sided limit, right? So this means that from both sides, that is why it's two-sided. So x approaches 3 from both sides of f of x is equal to 5, right? So when you don't see a sign here, that means it's a two-sided limit. So this actually means that x approaches 3 from both sides of f of x is 5. So limit exists only if left-sided limit equals right-sided limit. So if these two are same, left side and right side, if the values are same, 5 and 5, then we say limit exists. And if these two are not same, if you have a number 3 here and number 5 here, that means left side limit is not equal to right hand side limit. That means limit is not existing between the limits, right? So let's talk about definition. Limit will only exist if the left side limit equals the right side limit. So this is what we have said. Both sides must be same in order for the limit to exist. And in general, this is how we write. Limit as x approaches a from negative side. Here we had 3 in our example. We had 3 minus. Here we had 3 plus. So this is how we write in general. X approaches a from negative side, right? This is not any ordinary variable. This is basically a number. So any number would go here. when you look at other example. So x approaches a from negative side, that means x approaches 3 from left hand side, just like we have done in the previous example. And here we wrote x approaches 3 from positive side, that's using the previous example. So in general, this is how we write: x approaches a from negative side, from left hand side of f of x, should be equal to limit as x approaches a from right hand side, so the positive side of f of x. Then limit will only exist, right? Now when do limit doesn't do not exist? Limit will not exist if left side limit is not equal to right hand side limit. That means the two sides will not be same. This is how we denote limit as x approach a from negative side of f of x is not equal to limit as x approaches a from positive side of f of x. So these a's are numbers. In our previous example we used 3. So if the two sides are not same, we say they are not equal and the limit will not exist. So let's look at some more examples. If f of x is equal to this, x squared minus 4 over x minus 2, this is a rational function. Calculate the value of limit as x approaches 2 of f of x. So what happens when limit as x approaches 2 of this entire function f of x? This is f of x. So we are going to use again table of values method. Our point of interest is 2 this time. So let's put 2 in the middle. Let's put x and let's see what's the value of y. So we are going to write all the values that are closer to 2 from left hand side, and these are some values closer to 2. And now let's look at all the values that are closer to 2 from right hand side. So these are some values closer to 2 from right hand side. So now let's see what is the corresponding y values for these values, just like in the previous example. So you get 3.5, you get 3.9, you get 3.99, 3.999. Those are the y values that you are getting for these corresponding x values. And from right hand side, these are the values you are getting: 4.5, 4.1, 4.01, and 4.001. So what do you think is the number in the middle here? The middle number here is 2. For x, the middle number is 2. What is the middle number here for y? So we can actually see that the middle number here is 4. 3.999 and 4.001. That means the number here is 4, right? So we can see when we approach x equals to 2 from left hand side, from this side, we get 4. And similarly, when we approach 2 from right hand side, we also getting 4. The number here is 4. So left hand side limit is equal to right hand side limit, and that is why we say x approaches 2. Now you can see there is no sign here. This means that this is a two-sided limit, right? That means both sides are equal. This side and this side, they are equal, and that is why we are denoting as x approaches 2, and we don't have a sign here. That means this is a two-sided limit, and this is equal to 4. So limit exists. The other example, if f of x is 1 over x minus 1, calculate the value of x, or calculate the value of limit as x approaches 1 of this function 1 over x minus 1. So this time the point of interest is 1, so we have to see what is happening near 1. So if you use table of values method, you can put 1 in the middle, and you can approach 1 from all the side, from left hand side and from the right hand side. So let's see what happens from left hand side. These are the values closer to 1 from left hand side, and you can see some values that are closer to 1 from right hand side. So these are some values that are closer to 1 from right hand side. So let's see what happens in the middle here. So you get -2, you get -10, you get -100. So these values are going very far away. They are not coming near to any value. -2, -10 is very far, -100 is very very far, and -1000. So you are getting very far, and from this side you're getting 2, you're getting 10, 100, and 1000 again. So you can see when these values are approaching 1 from both sides, the y values are going further apart. This is going towards -1000. If I put any number closer to 1, like 4 nines, 0.0999 another 9 here, this will be a bigger number. And likewise here, if I put 1.0001, this number will go to a bigger number. So as we can see that from the left hand side we are going very far, we are not coming to a common value. So we will conclude here that x approaches 1 from negative side of this function f of x is not equal to x approaches 1 from positive side of f of x. And in general, two-sided limit, when we say x approaches 1, we don't put a sign here. That means now we are writing in two-sided limit that x approaches 1 of this function 1 over x minus 1 does not exist. That is what we said in our previous slide, that when these two limits are not same, left hand side limit is not same as right hand side limit, limit does not exist. So this is how we write using the two-sided limit. Limit as x approaches 1 of f of x, this is f of x here, does not exist. Why? Because they are not equal. Computing limits algebraically. Steps for computing. So limit as x approaches a of f of x. Substitute x is equal to a into f of x. If f of a is defined, then limit exists and the value of f of a is the limit. So we are going to talk about this. When you have a 0 over 0, then need to factorize. And when you have a number over 0, if the denominator is equal to 0, the limit does not exist. Right? So these are some key points you need to know. So let's do the example. So limit as x approaches -2 of this function here. You need to find the limit. So the first step is to direct substitute. If you direct substitute this, you will get 0 over 0. So if you want, you can try, you can put -2 here, -2 here, -2 here, and see what happens. You will get a 0 over 0, right? So in that case we will need to factorize. That's what we said in our previous slide, that we need to factorize that. So if you factorize the numerator 3x plus 6, so 3x plus 6, if you factorize, this is what you get: 3 into x plus 2 over, this is type 1 factorization. You need two factors that will add to give b, the middle term, and the same two factors that will add or will multiply to give a times c, right? So you can use factorization method, right? Type 1 factorization, and you can, if you factorize that, this numerator, you will get x plus 2, x minus 5, right? So clearly you can see that x plus 2 and x plus 2 here cancels out. So when they cancel out, you are only left with 3 over x minus 5. Now in this case you can substitute -2 in place of x, so that is why we put -2 minus 5. Now in place of x, -2 goes there, and when you simplify that you come to -3/7. So that's your limit. The other one is limit as x approaches 9, root of x minus 3 over x minus 9. So you can substitute 9 in place of x first. So if you put 9 here, this will become root of 9. Root of 9 is 3, and 3 minus 3 is 0. So numerator you get a 0. If you put a 9 here, it will be 9 minus 9, and again you'll have a 0. So numerator you have a 0, denominator you have a 0 again. So you have a 0/0 case. This means you need to factorize this. So if I factorize the top part, this is what I'll get. The top part is root of x minus 3. The bottom part I can write as root of x minus 3 into root of x plus 3. Right? So what I'm basically doing here is using difference of two squares. I can write this number x minus 9 as x root of x minus 3 and root of x plus 3, because if I expand this root of x times root of x, I'll get root of x times root of x, I'll get root of x squared, and root of x squared is basically x. And when I expand this, this will be 3 root of x. When I'll expand this one, I'll get minus 3 root of x. And when I'll expand -3 and this one, I'll get -9. So you can see that 3 root of x minus 3 root of x, they will cancel out here. If you want, you can expand this root of x minus 3 root of x plus 3. You expand this and you will observe after simplifying you will come back to x minus 9. Right? So this is your task. You can expand this denominator root of x minus 3 root of x plus 3. You expand this and simplify, you will observe that you come to x minus 9. Right? So we are writing this such that we can cancel with the top part root of x minus 3. So there you go, you cancel root of x minus 3 with root of x minus 3. You are left with 1 on top. Right? We are not left with 0, we are left with 1. The coefficient here is 1, so you are left with 1 over root of x plus 3. Right? So now what you can do, you can actually substitute 9 in place of root of x. So at this place, in place of x, you can put 9 there. So root of 9 is 3. Right? So 1 is there. This root has x, so in place of x we'll put 9. Why 9? Because x is approaching 9, so that is why we are putting 9 here. Root of 9 plus 3, and root of 9, you know, it's 3, so 1 over 3 plus 3 is 1 over 6. So the limit for this entire function is 1 over 6, and we found that algebraically. The last example, limit as x approaches 2 of x plus 3 into over x squared minus 4. So this is again a rational function. In particular, this is a bottom heavy function. So let's see what happens when x approaches 2 of this function. We are going to use algebra again. So we are going to do direct substitution first. So in place of x we put 2 here, and in place of x we put 2 again. So 2 plus 2 we have a 5, 2 plus 3 we have a 5, and 2 squared is 4. 2 squared is 4. 4 minus 4 is 0. So we said earlier on that a number over 0 is undefined, or we say limit does not exist. Right? So in any case, when you are evaluating limit, the first thing you need to do is direct substitution. You need to put x, the x value that it approaches to, in the function itself. So here x approaches 2, so you need to put 2 in place of x here, 2 in place of x here. And also in the previous one you also have to do it the same way. Alright, so we did not do it because those cases were algebra cases, right? You can simplify that algebraically, but here I have shown you by substituting the limits, right? So here I've put 2 in place of x, 2 in place of x, and then we have observed that it comes to 5 over 0. And when you have something as 5 over 0, we say limit does not exist, right? So this is what we'll have undefined. We say x limit as x approaches 2, x plus 3 over x squared minus 4 does not exist, right? And we have a last example here. The same way we're going to do that, we are going to use algebra again. So you have to factorize the top, factorize the bottom part here, and you can see that things will cancel out, right? These two will cancel with this. This one you can further simplify using difference of two squares, and you will come to see that you are getting something like this, right? And if you do direct substitution, you'll get answer as -4 over -6, which is 2 over 3, right? So that's the end of the lesson.